So, welcome everyone to Guided Study Group Week 16 of Math 141. So, this is the last week of Guided Study Group, and we don't have any new piece of materials. It's just basically a last-minute review for anyone who hasn't really who kind of need some final review before they take the exam. And so, I wouldn't, as I said, we don't have any new materials. I'm just gonna and I don't want to repeat what Dr. Katazina already did for the review. So I think her slides for reviewing purpose is very thorough and detailed. And so I think it's a very good reference for you guys to look at it and start your review from there. Here I'll just have like a checklist of what you need to know after exam 2 and before exam 2. So kind of like a checklist of the topics you guys need to know, and just to help you guys keep better track of the review process. And also I will go over some of the questions in the practice final exams as I look at the results of the people who already did it on Canvas of this year and also previous year. So just to kind of like clear out a little bit if someone already forgot quite a bit of thing and someone who is struggling with those questions. So first of all, we have the review for topics after exam 2. So that's going to be 40% of your final exam. We have power series, or particularly Taylor and Maclaurin series. Things that we need to know: how to find and determine what is the radius of and interval of convergence. Find a power representation of a function, either a Taylor series or Maclaurin series. And as I said, in this power series sections, it depends on how good you are at keeping note of what you're doing, just to keep track of it. Find the sum of a series by putting in Taylor and Maclaurin series. So kind of like you are given a series, and by putting it back into Taylor series, it helps you to find what is the sum of that. Write the nth degree Taylor polynomial of a function. So kind of like estimate a function using, say, maybe the third or the fourth degree Taylor polynomial. And going along with that, usually you're going to be asked what is the maximum error of that approximation. And that's when you use the, I think, Taylor estimation theorem or something. That one, but yeah, it's in the slides. Then we have parametric curves. We know we have to learn how to sketch them by using initial and terminal points, how to see their directions, what is the shape of the curves, say putting it in t and so on, and how to find derivatives on tangent line, which is take derivative of y and x with respect to t. Then we have polar coordinates, curves, and areas. For this part, we have a lot of shape of polar curves. So again, this is gonna come from your documentation, or I think in section 10.3, Dr. Kasher has a really good slide that show all the shape of that. And so I think if you retrieve it, looking back at the slides, you find it. And I think it's very helpful to like keep track of the reviews process. No, if not, learn how to sketch them, the directions, using special points, or maybe even put out a table of all the points that help you sketch them. Convert a Cartesian equation to a polar equation, or the reverse. For a Cartesian equation, you always find a polar coordinates, but for polar coordinates, you might not find one Cartesian equation. But I think in this exam, you should be able to do it both ways. It shouldn't be so challenging hard. Finally, we have how to set up and evaluate the area of the region bounded by two polar curves. Yeah, so that's what we have for review after exam 2. Then we have before exam 2. this is 60% of your test, but I would say you guys already studied for exam 1 and exam 2. So this part should be a quick review, but then the level that you may be asked in the final exam will be maybe like not the easy stuff. It's not going to be as detailed as exam 1 and exam 2. It's just going to be the representative problems. So you should have a look at like the end of most of my slides where I identify those problems. Or you can look at the review slides that Dr. Kasha put on Canvas. So mostly we're going to have the starting semester with 7 indeterminate forms of limits and L'Hopital rule. Then we have inverse function, derivatives, and how to find derivatives, domain, range, graph, and also use the right triangle formula. So this one I have a very helpful tables, I think, also in that week of review. So if you retrieve back, you're gonna see the table of all of the things that we need: domain, range, how the graph look like, how to use the right triangle formula, what is the derivative, and so on. Then we have improper integrals, type 1 and type 2. So improper integrals is where you have either the negative infinity or positive infinity as one of the boundary of the integral, or you have one of the discontinuity in the interval that we take integration. So again, review that part. Then the thing mostly for exam 1 is everything about integration. So how to take integration using U substitution, high degree trig integral, how to do partial fraction, trig sub, and so on and so on. So review, that is all of the integration technique that we have for exam 1. Then for exam 2, it's just basically a lot of sequence and series where you can use different kind of tests like comparison tests, integral tests, tests of divergence, ratio tests, root tests, alternative series tests, a lot of those tests. So review them and like know how to use them, and also there are some limitations that I make, and that's especially in the table. I think at the end of exam 2 when I have a review, I also put on the table for you guys, so that's a good place to look at. Then we have know what is absolute convergence, conditionally convergence, and divergence. Then review some of the special series. I think you guys should be really familiar now with trigonometric series, telescopic series, harmonic series, and P-series. So that should be all the things that we need for this final exam. Now, some of the questions in the practice exam that I find that is kind of challenging for you guys too. So let's do it here. So this one is just to review what is exponential function. So put in here exponential function. And so at the same time, I would kind of remind you guys to review log function as well. So this one is where you have when x approaching 0, x squared is going to approach 0 plus, and negative 5 over 0 plus is going to be approach negative infinity. So it's going to be limit of x approaching 0 e to the negative infinity. So this part is kind of like it's 0. So this is again back to the range and domain of the exponential function as well as log function that you have to revise. It's not hard, it's actually a very easy one, but so then next one is question 3. Find what is the derivative of that. So we have fx equal, so this is derivative of an inverse function. Then you have f prime of x is going to be, what is inverse of, what is derivative of inverse psi? It's going to be 1 over square root of 1 minus this thing square. And then multiply what is derivative of 2e x is that. So what we end up having is we have 1 minus 4 e to the 2x. So you have f prime of ln 3 over 10 is going to be 2. So ln of e to the ln is going to be just itself. Again, so 2 ln of that, so it's going to be 3 over 10 squared. Now it's going to give me 3 over 5 divided by 1 minus 36 over 100, which is going to be 64 over 100. Again, that is going to be 8 over 10 or 4 over 5, which is going to be 3 over 4. So again, this is just to review what is derivative of an inverse trig function, and also remember chain rule here. So yeah, somehow it was some problem with how to put them back again. So now evaluate this integral, and so this is where you use you can see the fact that 1 plus x squared is 1 over 1 plus x squared is the derivative of inverse tangent. So we have, if we use up all, we can just say is equal this 2 inverse tangent of x multiply d inverse tangent of x. This is going to be tangent of x squared from 0 to square root of 3. This one, inverse tangent of square root of 3. Now remember, the domain of tangent is from here to here, and not taking the two endpoint negative pi over 2 to pi over 2. We don't take that. So it's only, oh no, not the domain, the range. So the one at square root of 3 is where psi is equal square root of 3 over 2, and so that one's gonna be pi over 3 minus, when you have 0, inverse tangent of 0 is gonna be just 0, so it's gonna be pi over 3. So this one is not just what is the derivative of function, but also remember what is the domain and the range of that functions to be able to get the right corner for that part. And this is this square, so it have to be pi squared over 9. So now it's question 9. Determine whether the given sequences converges or diverges. Now this is a sequence. So when you figure out if it's converges or diverges, I think this is a hard one as well. It looks a bit confusing to me. You just find what is the limit of n approaching infinity of an. So you have a to the n plus a to the 2n plus a to the 3n, 1 over 3n. It's kind of like rewrite it. So here, when you take a to the 3n out, what you have inside is 1 over a to the 2n, 1 over a to the n plus 1, 1 over 3n. Therefore, you can have this part, and this part is basically just limit of n approaching infinity, a multiply the thing inside to that power. Now, if you say n approaching infinity, this thing is approach 0. This one also approach 0. So 1 to the whatever number it is, 1 to the 0 is also 1. So the answer is this is the sequence converges to 8. So the challenging part here is being able to see the fact that what is the dominating factor here, which is this term. And so when you take that term out, to remember, like when you have a plus b to the c, it's not equal a to the c plus b to the c, not that one. So yeah, everything have to come from the product or division. So from here to here, there's one extra step that I did. Actually, when you separate this one to the 1 over 3n, multiply this part to the 1 over 3n. But yeah, so that's question 9. Now we're doing question 10. Consider this series. Which of the following statement is true? The series is trigonometric for every choice of c different than -1. So c equal to -1. When c different than -1, then yes, this is the trigonometric functions because it's basically just a factor moved to the n. So like it's a number. So a trigonometric series. Now this is true. The series converges for c equal -1 over 3. So -1 over 3, the series will become 1 over 1 minus, which is going to give us 3 over 2 to the n. And the factor here, r equal 3/2 bigger than 1. Therefore, this is a divergence series. So this is 4. Now the last one, c equal to 1. Now the series will become 1 over 2 to the n. And to find what is the sum of this, we're gonna use the formula a over 1 minus r. The first term, a is the first term in the series, so it's going to be when you plug n equals 0 in, which is going to be 1. 1 minus the factor is half, so it's going to be 2. So this is true. So that is true, false, true. Again, this is not hard. It's just, again, just review, and basically I think it's just very easy. Just a lot of people might have forgotten that. Question 13, the ratio test. Find the interval convergence for this power series. Again, when you have power series and they ask you to find the interval of convergence, first you're going to starting up with either ratio or root test to find what is the radius of convergence, and you determine if you're going to take the two endpoints of that interval or not. So here you have limit of n approaching infinity, an plus 1 over an. So here we have limit of n approaching infinity. And you take absolute value, so you can ignore the -1 to the n part. So you have x plus 2 to the n plus 1, minus n plus 1, 4 to the n plus 1, multiply n to the 4n, x plus 2 to the n. And then this one is limit of n approaching infinity, x plus 2 divided by, multiply n over n plus 1, multiply 4. Now, as n approaching infinity, n over n plus 1 is going to approach. So limit of n approaching infinity of n over n plus 1 is going to be 1. So you can ignore that. And that's how you end up with just x plus 2 over 4. Now you want this part to be smaller than 1, or you have absolute value of x plus 2 smaller than 4, or you have x plus 2 between -4 and 4. So you have x is in between -6 and 2. So the radius of convergence is half the length of this interval, which is 4. And now you're going to figure out if you're going to take the two endpoints or not. I'll rewrite this over here. -6 Now when you have x equal -6, the series become -1 over to the n, also -4 to the n over n for n. This one is equal 1 over n, and this is harmonic series, and we all know that it's divergence. So we have again, another point is when x equal to 2, you have the series become which is very simple now, which is going to be -1 to the n over n. And this one, we already solved it when we learn about alternating series test. If we use alternating series test, you're going to find that this one is convergence by alternating series test. Therefore, our interval of convergence is from -6 without taking -6 to 2. We take 2. So this is the interval of convergence. Again, just 2 main steps. First is find what is the radius convergence and determine if you're going to take the 2 endpoints of that interval or not. Now, let's go to question 15. If the radius convergence of this power series is 9, what is that power series radius? So, we have n plus 1, cn, x to the n, radius is 9. Now we have this one. So I would say in this question, a very good approach to it is, what is the relation between these two that make it asking these questions? Now if you look at here, the second series isn't it this one when you take integral? So integral. So when you have integral of this, cn x to the n, is going to be half of 1 over 2 of this one. Actually, give me a second thinking about it. When we come to when you come from the upper one to the lower one, so okay, so the thing here is that when you have this radius is 9, so basically when you look at this thing, instead of x squared, you can think about it as the series of cn u to the n with u equal x squared. So again, the radius with respect to u is now going to be 9. So you mean x squared smaller than 9. Or you have absolute value of x smaller than 3. So here you have the radius with respect to x is 9, because whatever under n. So your absolute value of x is smaller than 9 here, but your absolute value of x here is smaller than 3 because the variable changes. So I think that's one of the ways to think of the problems. Also, if you want to think of it as the other way, I would say, I think it's also explained when you did the questions in the practice final exam, but I'll get back to you guys after I finish all of that. But I think this is the way that we're going to solve this problem, because when I look at my notes right now, I literally just write down one sentence, which is this part here. So that's how we actually do it, I think. There's two things. Alright, so let's go to question 16. Question 16 is find the power series representations for that for all of x in that interval. So we have fx is x over 1 minus x squared. This is equal 1x multiply this part. And we have the series for this part. If you take good notes of all of the example we did in that chapter, we're gonna have this equal n minus 1. Therefore, our series now become n x to the n. Or you can derive this one by coming from 1 over 1 minus x as well. And that the power series for this one, you definitely have it. Oh yeah, there you go. I think we found this. It's kind of like giving us, it looks very similar to this. If you take, what is the representation of 1 over 1 minus x? Yeah, that's one of the general case, but sure, I think the other one is a better way to think about it. When I finish this section, I'll have a look back at the slides on Canvas and see what is Dr. Kasher's response for it. So we have question 21, 22, and 25, and then we're gonna finish. So we have phi dy over dx for this parametric curve. Again, as I said, we're gonna basically find the derivative of y and x with respect to t separately. So it's going to be, that one is negative sine t. This one is cosine t divided by 1 plus sine square t, because that's the inverse tangent of sine. Therefore, we have negative tangent t, 1 plus sine square t, which is, oh, not divided, multiply actually. Negative tangent. So that's that. And then question 22. The curve with this equation in polar coordinates is what? So we have basically put it back in maybe Cartesian equation or something that is familiar for us to determine the shape. So we have r squared sine 2 theta is basically, if you separate this sine 2 theta so that we can relate to x and y, you have r squared multiplied 2 sine theta cosine theta. So basically this one is 2xy equal to 1. So this one is equal y equal 1 over 2x. So it's a hyperbola. The shape is basically, I think it's this one. No, this one. And over here it's going to be like this. So now we have the last question, question 25. Set up but do not evaluate this integral expression for the area lies inside both curves. Now, I would say in the exam, you don't have access to other software, so you will have to sketch this yourself. But just for the purpose of like showing this out, I don't want to spend much time trying to sketch it, because most of you guys, I think, should be very familiar with these already. So we're just gonna say we already have the graph, and we're gonna start to figure out what we have to evaluate. So the area lies inside both curves. So this part and this part. So the area. So now let's figure out what are the special point here that intersects with one another. So here, 1 plus cosine theta is, this one is r equal 1 plus cosine theta, and we have another one is r equal 1 minus cosine theta. Therefore, here we have, if we take the intersections that they have, so So you're gonna have cosine theta equal to 0. And the special point for that is pi over 2, 3 pi over 2. So basically at 0, they are at this point and this point. Then you go up, they cross here. This is pi over 2. Then they go down to here and here. And then you go back up to this part. This is 3 pi over 2. So my area, and as you can see, there's perfect symmetry here. So this part is the same as this part. So you can have the area you want to find is 2 times of this crossing part. And each of these crossing part is also twice of the area from one sleeve of this curve or the area of the just other sleeve from the other curve. So you have two ways to find this. You can do symmetry using the red curve. So 2 multiply 2 of this red curve. So from 0 to pi over 2 of 1 plus cosine, no, 1 minus cosine theta square d theta. Or you can take it as the blue one. So here's going to be pi over 2 to pi. So pi over 2 to pi, 1 plus cosine theta square d theta. Oh yeah, and then these area must have the half in front of it. Yeah, the half I always forget, honestly. But yeah, you should remember that. So again, this is not hard. It's just maybe you need some more practice with this part because we haven't really touched much on that except for a few examples. So you might want to look at examples in the book or like the suggested problems on Canvas to practice it. Now, as I promised, I'm gonna stop the recording a little bit, or actually just keep it. We're gonna look back at these questions. Question 15. Okay, let me pull it up on Canvas and so I am looking at it. Just give me a second. It's question 15, isn't it? Yeah, that's exactly what she wrote. That's similar to mine. So yeah, I think it's just the fact that your variable changes. So the radius is gonna change depending on the variable. So the variable here is instead of x is x squared now. So technically your radius is still 9, but that's with respect to x. But if you take it with respect to but if you're looking for the radius with respect to x, it's going to be 3. So that is your final answer for this. And so without anything else, I'm gonna end the sections here, and I wish you guys best of luck for the final exam. It's been a great semester working with you guys, and I hope to see any one of you in the future. Maybe we'll bump into one another. Who knows? But that's it. Have a great semester and have a great summer.